Okay, now that we know what frequency tables are and how to make them and how to read them, I want us to be able to graph them and to examine the shape of our data. So let's talk about the shape of data first. There are basically 4 different shapes and then one other one that we'll talk about at the end. But the first one is normal, which is also bell-shaped data. And you have probably talked about normal bell-shaped data somewhere in your life, but normal bell-shaped data has most of the data in the middle and then it spreads out. It doesn't have to be perfectly symmetric, but roughly, most in the middle, not as much on the sides. So bell-shaped data would look something like that. Okay. Then we have uniform data. Uniform data is roughly even. You get about the same amount in each class. So let's say that we were going to roll a die and you could get a 1, 2, 3, 4, 5, or 6. So I've got 6 different bars there. And you know, it's not perfect, but you would get roughly the same number as 1s or 2s or 3s or 6s. So uniform data tends to be flat. Flat-ish. It doesn't have to be perfectly flat. Then we have data that is skewed left. It trails off to the left side. And you can remember that if you think about, like, what does my left foot look like? 1, 2. So if your left foot looks like this, your data would trail off to the left side. Skewed right, then, is the opposite of that, and it trails off to the right side, and it would look like your right foot. Okay, so those are the 4 basic shapes of data. Okay. You'll also encounter data that we call bimodal. Bi meaning 2, modal meaning modes. It has 2 modes. So when you look at your data, there may be a whole bunch of data here on one side, pretend like that's straight, maybe nothing in the middle or very little in the middle, and then have a bunch of data over here on the right. So it's in 2 parts. And you get bimodal data if you're collecting data from 2 very different subsets in your samples. So it might be, you know, how many miles to work do people drive, or how many miles do people commute? And you have people that live on campus, people that live in a different city, people that ride a taxi, people that walk. Or you could be doing grip strength, and you could have like old men, young men. 2 very different samples would give you a bimodal distribution. Okay, going back and looking at our data, the pulse rate data, if we wanted to graph that in a histogram, I can't draw a histogram and have bars that go, I'm going to erase this so don't write it down, if it went 60 to 69, and then suddenly you have 70 to 79, and then 80. You know, that's just a dang mess. So we can't do that. So instead, we will either use the midpoints or our boundaries or just the lower class limits. And you can see it all different ways. But you're not going to see the 60 and the 69, the 70 and the 79. So 3 different ways that we could draw this. You could use your lower class boundaries, 60, 70, 80, 90, 100, 110, 120. And then over here on the other side, we will have our counts, the frequencies. And I think there were 2, 4, 6, 8, 10, 12, 14. there were 12 in the 60s, 14 in the 70s, 11 in the 80s, 1, 0, 1. Okay, so you could use your lower class boundaries and that, your lower class limits, and that would work. Another way that you will see this written is with midpoints. They'll put the number that's in the middle, 64 and a half, 74 and a half, 84 and a half, 2, 4, 6, 8, 10, 12, 14. And you'll get the same thing. You know, we had 12 of these, 14, 11, 1, 0, 1. So you get the idea that you can use your lower class limits, you can use your midpoints, you also could put your boundaries. You could put 59.5, 69.5. Any of those are valid and will work. Okay, so I hope that makes sense, and have a good day.